the Young's modulus of steel is twice that of brass. Two wires of same length and of same area of cross section, one of steel and another of brass, are suspended from the same roof. If we want to lower ends of the wires to be at the same level, then the weight added to the steel and brass wire must be in the roof ratio of. Okay. Now, here they are going to give the data. That means it is the Young's modulus of the steel is twice as that of the brass. Then we can know here that the Young's modulus, that is we can denote it by the symbol Y or E, no problem. Y is equal to FL divided by A into delta L. That means Young's modulus, that is nothing but the stress and the strain. Stress upon strain. Stress is equal to force by area, and strain is nothing but change in length divided by original length. Then denominator of the denominator will go to the numerator, that is FL divided by A into delta L. Then here they are given the wires are same length and the same area cross section. Then they are mentioned here A, I and delta L are same. A and L and delta L, all these are same here. Then we can write this one as Fs divided by Fb is equal to Ys divided by Yb. Since they are given that the Young's modulus of the steel is twice that of the brass, then we can write the Young's modulus of the steel is 2 times of Yb divided by Yb. Then we get the answer 2. That is nothing but it is a 2. It is in the ratio of 2:1. Option C is the right answer.